Hello everyone. In this session, let me continue the problems on Newton-Raphson method. Here is a question. Use Newton-Raphson method to find cube root of 27. So usually how you're going to write square root? Something like this, right? Square root of 27. Since it is understood you have 2 as a place value here. Now instead of 2, 3 is given, so it represents cube root of 27. So we have to find cube root of 27 corrected to 3 decimal place. In the sense we have to find the value up to 3 iteration. Fine. Now what we have to find is cube root of 27. You have to take that as x. Fine. So let me take x is equal to cube root of 27. Now we have to find the value of x up to 3 iteration. Now I can write cube root of 27 as 27 power 1 by 3. Fine. Now as we already done the problems like this, so I have to remove the power, that is 1 by 3 I have to eliminate. So what I have to do is I have to raise the power 3 on both sides, so that when you are going to do that you will get 27 power 1 by 3 into 3. So 3 get cancelled. You will get x cube is equal to 27. I'm sorry, question make it as 37. Fine. So it is 37, cube root of 37. So I have obtained x cube is equal to 37. So I can rearrange this as x cube minus 37 is equal to 0. Now we have to find a solution for the given polynomial x cube minus 37 is equal to 0. Fine. Now as usual, let me take given function as f of x. It is given by f of x is equal to x cube minus 37. Now let me find f dash of x. F dash of x will be x cube differentiation is 3x square minus 37 is constant, so that will become 0. Now we don't have initial condition given in the problem, so we have to find the initial condition just by giving the values for x. So let me give x is equal to 0. You will get f of 0 is equal to 0 cube minus 37. So you will get minus 37. Anyhow it is negative value. Now we have to find one positive value. So let me give x as 1. So f of 1 will be equal to 1 cube minus 37. That will give us minus 36, again less than 0. Fine. Now let me give x is equal to 2. So f of 2 is equal to 8 minus 37 is minus 29, again less than 0. X is equal to 3. So f of 3 is equal to 3 cube minus 37. That will give us 27 minus 37 is minus 10, so less than 0. Now x is equal to 4. F of 4 is equal to 4 cube minus 37. 4 cube in the sense 64 minus 37 will give us 27. Anyhow we have obtained a positive value. Now I can stop here and I can clearly say the root lies between 3 and 4. Let me write, therefore the root lies between 3 and 4. So I have to take 3 as x naught value. I have already told you in the previous session. Fine. Now what is the formula for Newton-Raphson method? It is given by xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So this is what the formula for Newton-Raphson method is. Now let me do first iteration. So for the first iteration I have to take the value of n as 0. So when n is equal to 0, let me substitute n is equal to 0 in the formula. You are going to get x1 is equal to x naught minus f of x naught divided by f dash of x naught. Clear? Now x naught I have already obtained, it is 3. So let me make a note of that. X naught is equal to 3. I have to find the value of f of x naught. So wherever x is there, replace it with x naught value. So you will get 3 cube minus 37. Fine. So 3 cube is 27 minus 37 will give us minus 10. Next f dash of x naught. Wherever f dash of x is 3x square. So replace x with 3 square. So 3 into 3 is a 9. So that will give us 27. Now let's substitute all these value in x1. You are going to get x1 as 3 minus 10 divided by 27. Or else I can write 3 minus of minus is plus 10 divided by 27. So let me simplify. 10 divided by 27, the value is this, plus 3. That will give us 3.370. So x1 is 3.3703. Anyhow, we have to find up to 3 values, that is 3 iterations we have to do. Now I have done first iteration, so let me do second iteration. So for second iteration I have told you n value should be taken as 1. Fine. So when n is equal to 1, let me substitute n is equal to 1 in the formula. So you are going to get x2 is equal to x1 minus f of x1 divided by f dash of x1. So x1 I have already obtained. Let me write it as x1 is equal to 3.3703. x1 I have already obtained. Now let me do f of x1 value. So f of x1 in the sense f of 3.3703. So wherever x is there, replace in f of x value. So f of x value will become 3.37. For first step I'll write the step for the first time. After that I'll simplify as it is. So cube minus 27. So let me simplify so that f of x1 will be equal to, see here, 3.3703 whole cube. I'm sorry, 3.3703 whole cube minus 37. So that will give us 1.2829. Clear? So that is what I have written. Now let me write f dash of x1. So f dash of x is 3x square. So 3 into, I'll directly simplify, 3 into 3.3703 whole square. So that will give us 3 into 3.3703 whole square will give us 34.076. Fine. Now I'll substitute all these values in x2. You're going to get x2 as 3.3703 minus f of x1 is 1.2829 divided by 34.076. Fine. Now let me simplify the value. First I'm going to simplify this. 1.2829 divided by 34.076. Fine. So I have obtained the answer. Next 3.3703 minus answer. That will give us 3.3326. Fine. x2 value I have obtained. But we have to find up to x3 value. Fine. So let me do the third iteration. So for third iteration, n value should be equal to 2. So let me substitute n is equal to 2 in Rabson formula. So you're going to get x3 is equal to x2 minus f of x2 divided by f dash of x2. You no need to remember this formula. You just remember this. When you have x1 here, you're going to get x0 minus f of x0 by f dash of x0. Similarly, x3, 1 less. So x2 minus f of x2 by f dash of x2. So x2 I have already obtained. From the previous iteration, it is 3.3326. Now let me calculate f of x2. So wherever x is there, let me replace. I'll calculate directly 3.3326 whole cube minus 37. So that will give us 0.01259. Similarly, let me calculate f dash of x2. So 3 into x2 is 3.3326 whole square. So that will give us 33.3186. Clear? I have solved f of x2 and f dash of x2. Now let me substitute in x3 so that you're going to get x3 is equal to 3.3326 minus 0.01259 divided by 33.3186. So let me simplify this. 3.3326 minus, open the bracket, 0.01259 divided by 33.3186, close bracket, press equation. You will get x3 as 3.3322. Fine. So they have asked us to find the roots up to 3 iteration. So let us start at third iteration. So the required root is x3 value. So I can write, therefore the required root is 3.3322. That's all. Everything is same. The only change is you have to take the unknown value as x and you have to make arrangement in such a way that you're going to get a polynomial like this. So rest of the procedure is same. Fine. Now let me solve one more problem. This problem is quite different. See here. Here they have not asked us to find the root. Instead, they have asked us that find an iterative formula. We have to find a formula to find square root of n, where n is positive number and hence find square root of 5. So in place of n, they have given 5. So we have to find first iterative formula for this, and I have to find a square root of 5 also. Now let me do. First we have to assume the unknown quantity as x. So as I already told you, let me take x is equal to square root of n. Now I can write this as like previous problem I have told you. So x is equal to n power of 1 by 2 I can write. Now I have to remove this power. So in order to do that, let me raise 2 on both sides, power 2 on both sides. So 2 get cancelled. I'll get x square is equal to n. Or I can write this as x square minus n is equal to 0. This is capital N. Fine. X square minus n is equal to 0. Now I have to find the iterative formula by using Newton-Raphson method. First I have to write Newton-Raphson formula. Xn plus 1 is equal to xn minus f of xn by f dash of xn. Fine. Now let me take f of x value as x square minus 1. Fine. Since we have asked us to find an iterative formula, so I have to replace x with xn. Procedure is x with xn I have to replace, so that you are going to get xn square minus n, f of xn. Fine. Similarly, let me find f dash of x. Here n will be constant. See here, something like square root of 2, square root of 3, so it goes on. So n is constant. So when you differentiate x square, you will get 2x. When you differentiate n, it will be 0. Fine. Similarly, let me write f dash of xn. Wherever x is there, replace it with xn. So you will get 2xn. Now we have to find iterative formula, right? We have already written the Newton-Raphson formula. We are going to find an iterative formula by using this only. So LHS, let me write as it is. Xn plus 1 is equal to xn. I have to keep as it is. Now I have to replace f of xn. What is the f of xn value we have in terms of n? Xn square minus n divided by f dash of xn is 2xn. Now let me simplify this. Simplification is quite simple. I have to take LCM, so that you will get 2xn square minus, I am going to multiply inside xn square plus n divided by 2xn. Fine. Now 2xn square minus xn square will give us xn square plus n divided by 2xn. Clear? Therefore, the required iterative formula is xn square plus capital N divided by 2xn. Fine. First sub question is finished. Nothing. We have to change f of x with f of xn and f dash of xn. Substitute in Newton-Raphson formula. You will get iterative formula. Further, what else is asked? Where n is positive number, obviously, and hence find square root of 5. We have to find square root of 5. So just the thing is, in place of n, I have to replace 5. That is, f of x will become x square. F of x is x square minus n, right? So in place of n, I am going to replace 5. Clear? Now I have to find square root of 5 value. Since I don't know the initial condition, I have to find the initial conditions. Fine. So let me give x is equal to 0. So when you give x is equal to 0, you will get f of 0 is equal to 0 square minus 5. Again it is negative. Fine. So when you give x is equal to 1, you will get f of 1 as 1 square minus 5 is minus 4, again less than 0. X is equal to 2, f of 2 is equal to 2 square minus 5 is minus 1. Let me write directly. Minus 1 is also less than 0. When x is equal to 3, f of 3 is equal to 3 square minus 5 is 4. Now I have obtained a positive value. Now let me stop here itself. Now I can clearly say the root lies between 2 and 3. So initial value I have obtained x naught as 2. Now let me do first iteration. Fine. Here I'll change xn is equal to xn square plus n divided by 2xn. Now the only change here is, for first iteration in the previous problem, what we are going to take as, we are going to consider in the Newton-Raphson formula, right? But here it is not the case. We have to use this iterative formula that I have obtained in the previous step. That is, xn is equal to xn square plus n divided by 2xn. So put n is equal to 0. So when you're going to put n is equal to 0, you're going to get x naught here, but I have already obtained x naught here. In LHS I have xn plus 1, right? I'm sorry. See here in LHS I have xn plus 1, whereas in RHS it is as it is. Let me write this once again. Xn plus 1 is equal to xn square plus n divided by 2xn is the required iterative formula. Why? Because LHS is xn plus 1. Fine. Now I have to substitute n is equal to 0 here. So I am going to get x1 is equal to x naught square plus in place of capital N what we have is 5. So in place of capital N I have to substitute 5. So let me substitute it. So you will get plus 5 divided by 2 x naught you are going to get. Now substitute x naught value, you will get 2 square plus 5 divided by 2 into 2. So after simplification you will get 2.25. Clear? Now let me calculate second iteration value. For second iteration n is equal to 1. So only change is here while calculating iterative values you are not going to use Newton-Raphson formula. Instead we are going to use the iterative formula. Remember, here the only change is this one. So when you substitute n is equal to 1, you are going to get x2 is equal to n is equal to 1. So x1 square plus 5 divided by 2x1. So x2 will be, x1 is 2.25. So 2.25 whole square plus 5 divided by 2 into 2.25. So let me simplify this. 2.25 whole square plus 5 divided by 2 into 2.25. That will give us 2.236. So x1 is 2.25, x2 is 2.236. Fine. Let me write one more digit. Now let me find third iteration. For third iteration n is equal to 2. Nothing will change. So n is equal to 2. And you substitute n is equal to 2 in the iterative formula, you will get x3 is equal to x2 square plus 5 divided by 2x2. Now let me replace. x2 is 2.2361 whole square plus 5 divided by 2 into 2.2361. You just use the calculator and simplify, you will get 2.2360. Similarly, here the number of iteration is not mentioned, right? So it is up to your wish. Let me stop at the third iteration. So therefore I can write the required root is 2.2360. I am repeating once again. This formula is quite different, where we have asked us to find an iterative formula. So first step, take an unknown quantity as x and convert it into equation form. Now wherever f of x we have going to assume, wherever x is there, replace it with xn. Similarly in the f dash also do the same, and in iteration formula you just substitute the values of f of x and f dash of x, and after simplification you will get one formula like this. So in calculation of further values like root 5, you have to use that particular iterative formula. So here in this problem we have asked us to find square root of 5 value. In this problem initial condition is not given to us, so that is why I am going to find the value by giving the values as x is equal to 0, 1, 2, 3. So I have obtained 2 as an initial condition, so I have to replace n with 2. n is equal to 0 for the first iteration, so x naught with 2 I am going to replace. So when you substitute n is equal to 0, you will get x1. So x naught I have obtained in the previous step. After simplification you will obtain x1. Now for the second iteration, n value will be same, that is n changes from 0 to 1. As you done in the previous problem, it is also same, but the only thing is substitution will be in iteration formula. So when n is equal to 1, you will get this. Here in this particular problem n value is 5, so that is why I have substituted this as 5. So for the second iteration, let me replace n is equal to 1. So I have obtained x2. Third iteration also same procedure, but here the iteration is not mentioned, so I have stopped at third iteration. Now you do the same problem and hence find the square root of 7 value. This is homework for you. Fine. Whatever the problem is there, just rewrite the same. Instead of 5, you just write 7 and solve by using the same procedure. Hope it is clear. So this problem is also similar to the previous one. Here is a question, find an iterative formula. Here also we have to find an iterative formula to find the reciprocal of a given n. Difference is here we have to find reciprocal of n. So remember, for a given value, suppose if a is given, reciprocal of a will be 1 by a. Similarly, here the number n is given, we have to find this reciprocal. So our x value will become 1 by n. I'm repeating once again. Here they have asked us to find the reciprocal of a given number n. So reciprocal in the sense 1 by n. Fine. Now using Newton-Raphson method, we have to solve this and find the iterative formula, and hence we have to find the value of 1 by 19. Clear? Now what I'm going to do is I'll just rewrite this problem. See here, I'll just cross multiply this, so I can write n is equal to 1 by x, right? So I shifted this term here, so I'll get n is equal to 1 by x. Now I can rewrite this as 1 by x. Let me shift this. You will get minus n is equal to 0. Now I have obtained f of x as 1 by x minus n is equal to 0, or as 1 by x minus n. Now what I have to do is, as I told you earlier, if you want to find iterative formula, replace x with xn. So when you replace it with xn, you will get 1 by xn minus n. Now let me find f dash of x. Remember, differentiation of 1 by x is minus 1 by x square. I'll write here, differentiation of 1 by x is minus 1 by x square. So I'm using the same formula, differentiation of 1 by x is minus 1 by x square. So as I already told you, n is constant, differentiation will become 0. Now let me calculate f dash of xn. Wherever x is there, replace it with xn. So that when I'm going to get minus 1 by x power of n square. So I have already told you, to find the iterative formula, I have to write the Newton-Raphson formula, given by xn plus 1 is equal to xn minus f of xn divided by f dash of xn. Fine. Now let me substitute f of xn value. It is 1 by xn minus capital N divided by f dash of xn is minus 1 by xn square. Clear? Now after simplification, since I have minus here, shift this, you will get plus here. Now xn square will goes to numerator, something like 1 by a divided by 1 by b. If you have, when you're going to shift, you will get 1 by a into b by 1. So I am applying the same concept here also. So you will get into xn square. One more step simplification will give us, let me take LCM here. So when you take LCM, you will get n into xn divided by xn, or instead of taking LCM, you can easily simplify this by just multiplying the term inside. Everything is same, so xn get cancelled, one term, so you will get iterative formula xn plus 1 is equal to xn plus 1 minus, since you have one more xn here, so let me multiply it directly. You will get xn minus n into xn is xn square. Now required iterative formula, I'll rewrite again. Xn plus 1 is equal to xn plus xn minus n into xn square. Xn plus xn is 2xn. So I can write it as 2xn minus n into xn square. So this is the required iterative formula for the given problem. Only thing is changing x with xn and substituting in the Newton-Raphson formula. Now the thing is, we have to find 1 by 19 value. In the sense, 1 by n value, in place of n I am going to substitute n. Fine. Now initial condition is not given. Fine. In this particular problem, I cannot give values of what we say x, right? So when you're going to give values for x, maybe n value is unknown. It may things may take complicated. So 1 by 19 value, you just calculate, you will get 0.05263. Clear? Now you can note that this value can be lies between 0 and 1, right? This value lies between, you can just write a statement here, this lies between 0 and 1. So I can approximate this value as 0.05, right? So I'll just round up this, I'll take only 2 digits in order to simplification. So I have written this as 0.05. So this value can be taken as x naught. X naught is equal to 0.05. I'm repeating once again. Find iterative formula. After that, I have to find 1 by 19 value using this iteration formula. Since initial condition is not given to us, so what I'm going to do is I have to find 1 by 19 value. I have calculated 1 by 19. I have obtained this. Since this value lies between 0 and 1, so I can approximate this to 0.05. Approximate value, in the sense after point I am going to take only 2 digits, and let me take that value as x naught. Fine. Now replace first, for the first iteration I am going to simplify here. For the first iteration, let me take n is equal to 0. So what you're going to get is, in this formula you have to substitute iterative formula, not in Newton-Raphson. Remember, I have to use this one. So x1 is equal to 2 into x naught minus n is here 19 into x naught square. Clear? Now I will simplify here. X1 is equal to 2 2 into x naught is 0.05 minus 19 into 0.05 whole square. So simplify this, you will get, I'll just simplify this, 2 into 0.05 close bracket minus 19 into close bracket 0.05 cap 2. So that will give us 0.0957. Clear? Now x1 value I have obtained. I have to find the second iteration value. For the second iteration, n is equal to 2. Substitute n is equal to 1, right? For the second iteration, n is equal to 1. Substitute here, you will get x2 is equal to 2x1 minus n value is 19, x1 square. So x2 will be 2 into 0.0957 minus 19 into 0.0957 whole square. So I will simplify 2 into 0.0957 minus 19 into 0.0957 gap. That will give us 0.01738. So this is the value of x2. Fine. Similarly, find third iteration. So for third iteration, x3 will be 2 into x2 minus 19 into x2 square. So put n is equal to 2 here. So you are going to get x3. So you will get 2 into 0.01798 minus 19 into 0.01738 whole square. So that will give us 2 into 0.01738 minus 19 into 0.01738 whole square. So answer is 0.0290. Fine. So since the iteration is not mentioned here, so let me stop at third iteration. Therefore the value is 0.0290. So whenever they asked us to find iterative formula, remember we have to replace x with xn and substitute those in Newton-Raphson formula. On simplification, you will get one expression for xn plus 1. That will give us iteration formula. Fine. So this completes Newton-Raphson method. In the next class, I'll begin with the third method, that is secant method. So please pause the video and note these questions in the assignment book. In the notes. What are the questions I am giving right now? You have to solve all the problems in the notes itself. And rest of the assignment will be followed from the question paper as you are doing in first sem. So you have to do the same in the second sem as well. You have to solve the question paper problems in the assignment and pause the video and you just copy down these questions. Only 2 questions I have given. So these 2 questions you just go through the video and solve using the same procedure. Simple problems I have given you for homework questions. So please copy these questions, pause the video and copy these questions, solve in notes. Continue in the next session. Thank you.